Okay, so this is one of two sets of notes that you're going to get in the series section about doing error bounding. Error bounding for alternating series was a topic that was added just very recently to the BC exam. So it comes up frequently in the testing because they're still adding new questions about this. The alternating series error bound, though, is actually the easier of the two because it's actually quite logical and easy to follow. So the idea here is you have some sort of alternating series. Okay? And we have to know that that series converges in order to even contemplate having error bound. All right, so the idea here is that because I don't oftentimes have an easy way to calculate the sum, the entire sum. Like if it's not a geometric series or I don't know how to make a sequence of partial sums, I really just don't have a way to get this total without doing a whole lot of unnecessary mathematics. But what I can do is I can say, well, how good is a partial sum? And for the alternating series, a partial sum, like sum n equals 1 to some number instead of n equals 1 to infinity, is completely calculatable in a short period of time. And oftentimes it's really close to the infinite sum. So what we want to say here is I want to be able to say, what is the difference between n equals 1 to infinity of this alternating series and its partial sum up to k. So it's the same series, but in one instance, we're going to take it to infinity, which is the thing that we can't calculate. And in the other instance, we're going to take it to some finite number k. What's really neat here is that if it's an alternating series, this only works with alternating series that converge, the difference between these two things is less than or equal to the next term in the series. So if I add up the first k terms, the difference between that and the infinite sum is going to be less than or equal to the k plus first term. So you take the alternator off, right? So this is just the non-negative positive part of the term. So let's give an example of this and show how this works out. Okay, so a very simple alternating series that we know converges is the alternating harmonic series, but we have no idea what this converges to. So we're going to let S sub k be the kth partial sum of the alternating harmonic series. And we want the k so that we are within 0.1 of the actual series from n equals 1 to infinity of negative 1 to the n times 1 over n. So we want to be able to get a correct answer for this within 1/10 of a unit. All right, so in this series, b sub n is just 1 over n. So we know this. We know like the 10th b is 1 over 10. That gets me to 0.1. That's not within 0.1, right? So if I go to the 11th, I get 1 over 11, which is 0.09 repeating, which is definitely less than 0.1. All right, so if I bound the error by the 11th term, right, which means that k plus 1 is 11, this implies that k equals 10. So if I add up S sub 10, the first 10 terms of the series, so that'd be like 1 over 1 plus or minus a half plus a third minus a fourth all the way out to 1/10. If I added those up, that number is going to be within, so this is within 0.1 of the sum from n equals 1 to infinity of -1 to the n times 1 over n. So why does this matter? Because I can't calculate this, but I can calculate this. So, and I know that this is within 0.1 of this, and if I want to make it tighter, I just go more terms. I make that 10 bigger until I get to the next term, which gets it to where I want it to be. So if I think about this, if I actually take this sum, which I did earlier, I get -0.6456. Now, I don't know what this is, but I know that it's between -5456 and -7456 because it's bound by something that's less than 0.1. So the difference between this and this has to be less than that, and I know that this is this. So now I have a range of values that's pretty tight, right, for what this actually is. All right, so there is the idea of alternating series error bounding. There's guaranteed to probably be at least a multiple choice, if not a free response question for the next couple of years on the BC exam of this, because this is a relatively new topic on the BC exam.